Hello, welcome to this video. In the last two videos, we calculated the size of the variable, and in this video, we shall figure out a way to develop an algorithm to convert a number to any base you specify between 2 and 36. Typically, we use 0 to 9 and A to Z for encoding, making it add up to 36. If you want to increase the count of your base, you can include lowercase alphabets, that is A to Z encoding, and that is going to add up to 62. But in our example, we shall only consider the case of 0 to 9 and uppercase alphabet A to Z. We have parseInt method which takes in a number and converts it into an integer. ParseInt takes in an additional argument which takes in the base. If you specify the base, it's this one, that is the radix place. If you specify the base, it's going to make the specified number display in a different format. For example, we pass string A as the first argument and pass 16 as the second argument. We are going to get the output as 10. I'm running it again. Here we have 10. Okay, now if we pass 1010 as the first argument and pass 2 in the second argument, you'll get the output as 10. Your output is going to be in the base 10 format. Let me run it. See, you have it as 10. Now, let's try converting 255 to base 16 and see what our output is going to be. I'm running it. Let me clear the console. Okay, we have 597. Strange, isn't it? We expect the output to be double F, but we get a totally different result. It's because parseInt gives out an integer and FF are not integers. To solve this issue, let's create our own algorithm. But before we jump into our code editors, let's analyze and figure out a solution that we can code them in the next video. I came across this solution in the web, and this is one out of many solutions out there. We are all familiar with modulo operator and division operator, so let's use them as a tool. We have 200 divided by 7, and 200 is the numerator and 7 is the denominator. We know that 200 divided by 7 is going to give us a floating point number, so that's the reason we are floating it down to integer value when we divide it by n divided by d. Now you see this formula: n is the numerator, d is the denominator. N is equal to d into mat.floor n divided by d plus n percentile d, that is n modulo d. When we compute this, we get the numerator as 2. No matter what your numbers are, this formula is going to give out the number. In place of 200, if you had 300, it would have given you 300. If it was 333, it would have given you 333. This formula is going to come handy for our solution. Now let us find out what the base 5 number is going to be when we pass in 282. Here n is 282, b is 5. 282 is equal to mat.floor n divided by b into 5 plus 282 modulo 5, that is equal to 56 into 5 plus 2. Now rewriting it as, we can rewrite it as 56 into 5 power 1 plus 2 into 5 power 0. We found out the number for 5 power 0 and 5 power 1. Here, this is the 0th position and this is the first position, and that was 56 in our case now. Now 56 is a big number for the 5 power 1th position. The number should be between 0 to 4 to satisfy our solution for base 5. If the base was 10, the number should be between 0 and 9. If it was 13, then the number should be between 0 and 9 and A to C. You get the idea. Coming back to our example, 56 is a big number, so let's apply the formula again for 56. We are applying this formula for 56 and we are keeping 5 to the power 1 aside for now, and after we compute the solution, we shall add 5 power 1, that is, we shall multiply the solution with 5 power 1. Now 56 is equal to mat.floor n divided by b into 5 plus 56 modulo 5, that is going to give us 11 into 5 plus 1. Now this can be written as 11 into 5 power 1 plus 1 into 5 power 0. That again, now multiplying this with 5 power 1, we get 11 into 5 power 1 plus 1 into 5 power 0 into 5 power 1 plus 2 into 5 power 0. This 2 into 5 power 0 is this one. 2 into 5 power 0, this one. Cool. Now, we can rewrite this as 11 into 5 plus 1 into 5 power 1 plus 2 into 5 power 0. Again, rewriting it as 11 into 5 power 2. That is, we are solving the equation. 11 into 5 power 2 plus 1 into 5 power 1 plus 2 into 5 power 0. Now, we have 2 in the 0th place and 1 in the 5 power 1th place, that is this one. Now we have 2 in the 0th place and we have 1 in the 5 power 1th place, and we have 11 now. Again 11, now again 11 is a big number, so let's break it down too, and when we break it down we get 11 is equal to mat.floor n divided by b into 5 plus 11 modulo 5 is equal to 2 into 5 plus 1. Rewriting it as 2 into 5 power 1 plus 1 into 5 power 0. Now multiplying it with 5 power 2, that is 2 into 5 power 1 plus 1 into 5 power 0 into 5 power 2 plus 1 into 5 power 1 plus 2 into 5 power 0. Now we can rewrite this as 2 into 5 plus 1 into 5 power 2 plus 1 into 5 power 1 plus 2 into 5 power 0. We get the final solution to be 2 into 5 power 3 plus 1 into 5 power 2 plus 1 into 5 power 1 plus 2 into 5 power 0. That is, we have 2 in the 0th base, 1 in the first base, 2 in the second base, and 2 in the third base. Cool. Now what? Now 5 power 3, that is 5 to the third base as number 2, and it's smaller than 5. But we can observe that the values we got for 5 power 0, 5 power 1, and 5 power 2 are the modulus value. This one, 56, 282 percentile 5. The 0th base was 2. 56 percentile 5, it was 1. 11 percentile 5, it was 1. See, you see the pattern, 2, 1, 1. But this 2, we got it after the division. So let's make sure we get a value from the number we are modulus as well. So let's use the formula again to number 2. Here 2 is equals to mat.floor n divided by b into 5 plus 2 percentile 5 is equals to 0 into 5 plus 2. We can rewrite the solution as 0 into 5 power 1 plus 2 into 5 power 0 into 5 power 3 plus 1 into 5 power 2 plus 1 into 5 power 1 plus 2 into 5 power 0. And finally we get 0 into 5 power 4 plus 2 into 5 power 3 plus 1 into 5 power 2 plus 1 into 5 power 1 plus 2 into 5 power 0. Now we have a complete solution, and you can consider 0 in the 5 power 4th place to be an indication that you can stop here now. So 282 base 10 gives us 21125, and we have found a solution. Now we are done with figuring out a way. Now we are done with Now we are done with figuring out a wave phase. Now let's see a pseudocode to write our algorithm. Okay, I'm shifting to the third page. Okay, okay, I'm sorry. Okay, this is fine. Okay. Now let's create an empty array and assign it to the variable myArray to store the values, that is, the values obtained at the respective bases. In our example, the values were 2, 1, 1, 1, 2. Let us loop through the number until the number is greater than 0. We shall stop when the number reaches 0. While n is greater than 0, m is equal to n percentile b, n is equals to mat.floor n divided by b, and we are pushing it to myArray. We are pushing the modulo value inside of the array, and now the algorithm returns an array of digits in the specified base b, a representation of the decimal in base b. There is one problem in this method. We usually want to return an encoded number for digits higher than 9, but our solution returns a number and not the encoding. Now let us write the final phase for our solution, the encoding part. Okay. We are limiting our base to less than or equal to 36. So we need to encode our digits from 0 to 9 and A to Z. Mapping the digits in our array to the character mapping our digits from 0 to 9 and A to Z in our array will do the trick. The simplest way to do this is, given the array of digits to encode, this one, we create a string with as many characters as required, in our case 0 to 9 and A to Z, and use their indexing for our encoding character map. I'm assigning it the variable character map. Let us assign the, okay, already told you. And character map is going to be 0 to 9 and A to Z. We have an array that is myArray, and we are looping through it. We use for-of loop in our solution. We are going through the loop, and we are assigning the value inside of the character map to encode the variable. And we are assigning it to the variable encoding. We'll do the coding and have a walkthrough step by step in the coding video. Now, if the length of myArray is greater than char map, we shall throw an error. I know this video has been long and tedious. We shall do the coding in the next video. Thanks for watching. See you in the next video.